Welcome, everyone, to the first ever State of the AR Cloud Symposium and Showcase. And also, welcome, and welcome also to everyone who is watching this event on our live stream on YouTube. And hello to my 12-year-old son who really wanted to come here. He's also watching. I'm going to say this is Norwegian. Jeg er stolt av deg, son. You know what that means maybe, but at least if we do this next year, I'm going to bring him here. So, I am Jan-Erik Vinje, the Managing Director of OpenAR Cloud. It is my great privilege and honor on behalf of the really awesome OpenAR Cloud community to get to welcome everyone here to this full-day event at the Ericsson Experience Center in Silicon Valley. First, I would like to thank the sponsors who have made this event possible. Ericsson, this is a splendid venue that you have provided here in the Experience Center, and I also want to thank Christine Swanson and Taryn Corbett Drummond for providing a ton of practical help. I also want to thank Context Grid for sponsoring the after party. It's going to be really exciting and fun, and it's going to be at the Villa Bar in Iceland in Redwood City. And you will get opportunity to experience exciting new ways to order drinks using holograms. This is using AR Cloud technology. And you're also going to meet a lot of mingle and hang out with really great people. And third, I want to thank Brainwave. It's Tony here. Tony is there. He has helped finance this event so that our newly founded non-profit organization don't run a deficit on this event. So that's super helpful. And okay, how are you feeling today? Are you excited? Yeah, I am very excited. And maybe some of you share this sense that the computing paradigm we are here to talk about and show some early glimpses of today, it could be a big new leap forward for humanity. Maybe you are just curious, or maybe you're already passionate about AR Cloud technology and you have decided to take part in shaping its future. Maybe some of you also feel a worry that the consequences could be bad if we allow this technology to be misused. Maybe you are looking for ways to prevent bad outcomes. Maybe someone present in the audience has a brilliant solution. Whatever the reason for coming here, we are very happy that you are here. We are super stoked about all the awesome people here today. And we think we are going to have some really great treats for you. We'll start off with a press conference about the first State of the AR Cloud report. Also in the press conference, we will bring someone on stage for a surprise announcement, so stay tuned. After that, we will hear a few words from our sponsors, and right before, let me see, and after that, we will have leading AR Cloud providers demonstrate and showcase their latest breakthroughs. So that's going to be exciting. That's a glimpse of the future. After lunch, you will be given the opportunity to try that hands-on. And next, you can participate in our breakout sessions led by OpenAR Cloud Working Group chairs. And finally, we've got a spectacular group of panelists to discuss privacy and security in the era of constant reality capture. We hope you will have a great time here and gain some new insights. Now on to our next point in the agenda. For that, I'm going to bring on Christine Perey, a governing board member in OpenAR Cloud. She's a pioneer with 10 years of experience in AR and interoperability. She formed the community for open and interoperable AR back in 2009. And she later co-founded the Augmented Reality for Enterprise Alliance, also known as the AREA. I first had the great pleasure to working with her a little over a year ago, about 6 months before OpenAir Cloud was founded. Her contributions have been essential for helping build OpenAir Cloud to where it is right now. So give a big round of applause for my dear friend Christine Perey. So other way around. A lot of you have heard about OpenAir Cloud, but I'm going to try to give this elevator pitch using video. So Alina, sitting here, she compiled this teaser video that is sort of like the elevator pitch. This is a little bit fiddly because of PowerPoint.
Our physical reality is changing. The internet is moving off screen and out into the world around us.
Run over there to get the microphone.
Impacting every aspect of our lives, culture, and economy. This feature is made possible by AR Cloud technology, which includes machine-readable maps that tech giants and startups are currently spending billions of dollars to create. To reach its full potential, AR Cloud applications, content, and experiences must be accessible and work seamlessly for anyone, anywhere, on any device, without unjustified restrictions. Above all, personal, private, and sensitive data collection must be limited, compartmentalized, and protected at all costs. We must earn and preserve trust through open and interoperable systems that deliver authentic shared experiences people can rely on. The time to act is now. Join us at the dawn of this new era and help influence how it all begins. Visit openarcloud.org to get more info, join working groups, and get involved, committing your time, talent, and resources today in order to ensure a better tomorrow.
Yeah. Oh, just went on YouTube there. Let's try. Shouldn't the clicker go? There we go. So the OpenAir Cloud Association, our mission is that we will be driving the development of open and interoperable spatial computing technology and data and standards to connect the real and the digital worlds for the benefit of all. And now I think Christine is I'm gonna say a few words of our larger vision. So what you notice here, it's not like one little thing. It's a wide angle. We're having 10 working groups looking at very different perspectives into real-world spatial computing, and that is, I think, a core asset for. There's nothing like this in the world, where people from all over the world, representing very different professions, are trying to solve the same bundle of problems together. So we're about, if we go through them, the basis of the entire thing, if we're going to make this a great opportunity for everyone, it's going to be inspired by the open web. So you want to have it as open and interoperable as possible. The same way you could open a web page on any device, and you can visit any web page made by any developer. That's such a powerful concept, and that is a template that we need to bring onto the era of spatial computing. We do not want the walled garden. It's bad for consumers. It's really bad for developers who has to target a number of platforms. And importantly, the next one, open, inclusive ecosystem participation. We are building this together as a whole planet. We want to have a diverse community contributing to this. Not just a bunch of geeks in Silicon Valley. We need people from all over the world, from all walks of life, to have a say in their future. It's going to affect them in significant ways. On the note of open, we are all about open source, open data, and open R&D. That is good for along many different dimensions, but one thing is accelerating the innovation cycle. You get it much faster to the future you want, and the future that other people want, if the industry is able to start collaborating on some of the key components. So a core, if you look up in the corner, you see the standard outputs for machine readable and searchable reality. The whole fundamental part of this is that we make the world machine readable. That doesn't help you if there's like 20 different ways to describe this world that is incompatible. So we have to converge on some type of common understanding of how you describe and index both the real world that you have captured and also the content that you layer on top of that. And yeah, the UX part, we have a very intensely passionate UX working group. And they are really, this is a new opportunity to do something that is sort of mind-blowing. I was talking with Christine yesterday about the button that was inspired by the real world that jumped up to the real screens, no, to the virtual screens, and we were like moving our mouse around indirectly to have the pointer come over the button, and then we click it. So it's like sort of a half-baked way to interact based on something we're familiar with. But when you have fused the digital and physical realities together, that's an opportunity to actually use our natural capabilities. So we are very familiar with interacting with the physical world, and then we actually bring back the real button as a virtual button that you can touch with your hands. We got somewhere in this room, we got Jason Fox from Holland. He has tried playing on a piano with his fingers. It's a piano that doesn't exist, it's only virtual. But this technology is getting so powerful now that we get this direct. So for UX, this is an enormous opportunity to reinvent how we relate to the digital world. But we have to also be very careful about safety issues. I've experienced this myself. If we augmented what we see only through, even on a smartphone, and I overlay something on the real world, that can confuse me. I could have tripped if I have trusted what was on the screen. Instead of looking at the pavement, I could have thought the pavement was slanted. I could have fallen into the road and being hit by a bus. So we need to be very careful about a number of issues related to safety and security. Yeah, and the business models, that's really interesting because we're now in Silicon Valley. It powers the whole world, but it's very centralized. All the data comes in here, and all the users are all over the world. That's not a good paradigm for spatial computing because the data you're working with is typically highly local. So you don't want the long ping. Like technically, it's not good because for traffic, you need to have very short ping, and the data transfer costs are much larger if the data has to travel across the world. So the technical basis is that we need to decentralize, and that presents a lot of really interesting opportunities for new business models that I think could empower local business and communities in new ways. And I think we only have the last one, the respecting local governance and personal privacy choices. Privacy is a big deal for OpenAI Cloud. When we launched last October, we published a draft privacy manifesto for AI Cloud solutions. So it's core, it's top of our minds to figure out how we can solve privacy in a world of reality capture all the time. But we also want to respect not only the individual choices, we want to respect how communities and local governments, how they want to shape their society. And they need to be able to affect how this technology is working. It cannot be decided in a business meeting in Silicon Valley how rules and regulations are able to operate. So there needs to be flexibility built into the ecosystem that allows local governments to really be in charge and respect we the people. So with that, I think Christine is gonna say a few words about the first ever State of the AR Cloud report. You wanna talk a little about the working groups? You can.
We're going to come back to each one of these in a
Yeah,
moment.
yeah.
Thank you, and thank you all for being here and joining us today. It's very exciting. Glad to be here. Appreciate your attention. As the OpenAR Cloud was forming, there were some decisions that had to be made about this vast scope and how we were going to break it up into some actionable working groups. And it was through collaboration with some of the governing team members and some of the people who were advocates for these different topics that we defined these 10 working groups. Over time, we discovered that we needed to merge some of them. Some of them have taken higher priority and have grown very, very nicely. And others are waiting for you to come and contribute, and for others to make them successful. So we're going to be, I'll be talking in a minute about the organization of the report, and we'll be coming back to these different topics that are on the screen and that define the working groups. As you've heard, today is very, very important for us as an organization and for, we believe, everybody in this room and on the planet, because it's an opportunity to share what we have learned over the last 6 to 12 months and what about 39 subject matter experts collaborated on in the last 2 months in a very intense way. And I don't know how many of you have done collaboration in such a large group on one document, but it was an extremely rewarding experience. And I think that there's a lot of contributors and a lot of people that I know I owe a debt to for contributing to this. So I spoke and will be explaining to you how those 10 working groups fit in to the report. There were partners of the OpenAR Cloud Association. If you're an individual, you can become a member. If you are a company, we'd call that a partner. So that's a little subtle difference. And all of the partners and the people that work together produced a report that is very comprehensive and has been just freshly laid out. So that's what we're going to talk about. You know, as you've heard, this whole concept of AR Cloud is on the one hand new, but on the other hand, many of the concepts are familiar to those of us who have been in the world of XR or VR and AR. So it's not entirely out of the blue. It's not an abstract concept. And there are reasons that this has been building over time. So one of the chapters of the report is about the drivers that are causing a shift from just AR on a device or AR as a device-driven experience to a cloud and a mixture of on and off device experiences. So we talked about in the report 4 different technologies that are converging, and as a result of that convergence, sometimes very clearly, but sometimes indirectly, the AR cloud is becoming more possible. For example, I see some of you in the room today who have been working, some of you for 10 years or more, on making 3D assets easier to produce, easier to share, easier to consume. This is a trend that is larger than any individual. Same with the Internet of Things and these fantastic networks that we have available to us, and the last 5 years, the explosion of artificial intelligence and machine learning, which had already been in the academic and research community for longer. So there are these converging technical trends. In addition, there are people who, there are other trends that are related to society, to the human, not necessarily to the technology always. So the humans who are seeking a richer life, maybe more balance in their life, or like some of us, less balance in our lives, but that's a personal choice. And so, being able to articulate and to make those choices today as a society is a really long-term trend. And so sometimes we seek autonomous driving or shared rides, like many of us got here today. We seek to stimulate our minds through our whole lives and to educate those around us with our knowledge, as we're doing here today. So there's a lot of these topics that are explored in the chapter about the drivers. And finally, there's these business drivers. Companies, be they to increase the productivity of their workers or to impact their bottom lines, are always improving their products and their procedures. And in some cases, we are being asked, invited is a nice word, to upgrade our technologies because we can take advantage of new features, but also to protect us and to have better security and other benefits. So finally, there's certainly a lot of business incentives to reduce time, to reduce risk, and augmented reality, and in particular, the AR cloud can help in those ways. So I think at this point, we have a special feature, and I will be coming back in a minute, but I'd like to turn the clicker over to you.
That was very good. Thank you, Christine.
I'll be back.
So I'm very excited. There's someone here in the audience, and we have talked a little bit about this in advance. And with me here, I have a special agreement. So I would like to invite Kavya Perlman on stage with me from the XR Safety Initiative. And today we announce that we are entering a strategic partnership to collaborate on privacy and security in the realm of real-world spatial computing. And also, would you like to say a couple of words about some of your... You could take this one. Yeah.
Hello, everyone. Thank you so much for being here. This is such a significant day for all of us. It is a historic moment in time where we're going to sign this agreement in between OARC and XR Safety Initiative. XR Safety Initiative was literally found a few months ago just so we could stop begging for permissions and build standards that will literally define and encourage people to drive privacy, to advocate for privacy, to adopt privacy, security, and ethics in AR, in VR, in XR overall. The main challenges that we want to address, especially XR, specifically XR Safety Initiative, there are 3 key components. So organizations, individuals, and policymakers. So if we address and introduce these standards, policies, guidelines by the means of research and collaborations like we're going to do, hopefully will be able to build these standards. And hopefully over time, as the policymakers come to the table, they're going to need guidelines. They're going to need advice from technologies. And that's the one thing. So just want a little bit about myself. I was information security director at Linden Lab, maker of Second Life and Sansar VR platform. So my experience there, sort of guided me to learn about these challenges. And then prior to that, I was working for Facebook, doing third-party security advisory during US presidential election time. So that experience, again, tells me that it's not that organizations are really evil or want to do bad things. They just really need guidance. And we are at the crossroads of mass adoption. As the mass adoption takes off, as the mass adoption happens, we and other organizations like ourselves really intend to get it right. So this is such an honor. Thank you, Jan-Erik. It's such a pleasure. And we look forward to collaborating. Absolutely.
Thank you.
We have documents here. So would like to sign first?
Sure. It's a pleasure. And there is another copy.
Yeah, I think it's over there.
Yeah, okay. And should I date it? Today is quite a significant day. Yes, 28, 5/28.
Fantastic. Now we are talking. We have taken the first important step. You want to tell about this exciting new outreach campaign?
Oh yes. So that's the other thing. I was talking to I was in the UAE just a few weeks ago. And I was talking to our Middle East strategic advisor, George. Amazing person. And thank you, George, if you are listening, for that great insight. We had this amazing discussion where we learned that every industry and every domain has literally paid so much attention. So think about PCI and banking stuff. So when they moved to digital transformation, when they did the technology transformation, they paid so much attention. They put so much money into technology transformation. But what we really left behind is the stakeholders, is the people. So afterwards comes the phishing simulation, don't click links, don't do this, but that's after the effect. What we want to do here, especially with XR domain, is we don't want to leave anyone behind. We want to bring every single person stepping into the domain of XR, which is why George and I discussed this amazing insight, and we are starting this awesome initiative. It's an initiative dedicated to media awareness and just individual awareness from all levels of stakeholders, from the individual to the organization. And we are calling it Ready Hacker One. It's a platform which would basically campaign, advocate, and spread awareness about the implications, about the security, privacy, and ethical implications, and hopefully, potentially, spread solutions that you guys are developing that we would collaborate on. And that's why I'm so glad to announce Ready Hacker One platform today here that XRSI would be advocating for, and we would together would collaborate on that platform to initiate and to spread awareness around these challenges that we're facing in XR. So thank you.
Wonderful. You want to hand this back to me, yeah?
Thank you.
let's see what the next slide is. Yes. Yes. So one of the challenges that I think we all share, and we're going to be discussing for the next few minutes, is how to position ourselves within this pre-existing ecosystem, but with some new twists and turns. And so in discussion with my colleagues, I started thinking about how so much of what we're doing is connecting the physical world and the digital world. And what came before was open linked data. So this particular graphic comes from an open linked data initiative in which we were, and it's not a past thing, it's very much alive and growing. This is the figure that is published on the openlinkdata.org website. And for me, it expresses all of the different kinds of data, and it gave me an opportunity to think more closely about how at the center of the AR cloud is data. And that in one analogy, it's like the molten lava in the planet, something around that's moving, it's dynamic. But another dimension, at least for AR cloud, is it's continually expanding. And it's expanding more and more rapidly. So the analogy is maybe more like the universe that is growing and always getting more complex. So I used this this metaphor and these ideas, and I'll be speaking about it more tomorrow in much more detail, but I wrote about them in a chapter in the State of the AR Cloud report. And I invite you to read about that and give feedback and discuss how we can improve this. The idea is that we have this data at the core, but this layer, the AR presentation system, has already been out there. It's already out there. People are using HoloLens and Magic Leap and monocular displays and their smartphones to consume experiences with the real world. But in the AR cloud, we're going to hope and strive that there be more of an intelligent layer or an AI agent that is accompanying that user as they have this presentation system with them. An AI user agent that will simplify and reduce our cognitive load. So that's very briefly what I have on this layer. And of course, there's the physical world, because without the physical world, there is no augmented reality. The presentation system merges the digital and the physical worlds. And in this framework that I'm proposing, we have what I call the processing zones. And that's this dark, wide band here with different tasks or functions that are necessary to fulfill the vision that Jan-Erik was speaking about. And they're all important. We're going to be speaking a little bit more about them in the next few minutes. But these are all important domains, and it's certainly highly likely that we'll add more to these important zones as we better understand them. But right now, let's speak about them in those general terms. So this is a part of the State of the AR Cloud report. After the framework, there is a very, very massive chapter. It is essentially this collaboration that I spoke about, in which each of the working groups was tasked to define how their working group fit into this bigger picture. How are they going to contribute to the benefit of all, as we've spoken about, and as is in the vision. So now we're going to go through and just give you a few highlights of each of those chapters. Jan-Erik, do you want to take this one? And there's...
So what you see here is a visualization that aims to represent the really most fundamental part of the data. And that data is a representation of the real physical world. There are different ways to talk about. Some describe this reality layer that we have here as like a single thing. But it's not that easy. I think we need to split the reality layer of the AR cloud in two for a number of important reasons. So I'm from a geospatial company. We do GIS technology, and we have this base layer, the ground truth, and that is stuff that remains on the location. So it's the terrain, the roads, the buildings. Those are mostly static, even though sometimes we build new stuff. Sometimes there's an earthquake or a volcanic eruption, but most of the time it doesn't change. And then there is where the real action is going on, in the real-time layer. That's where all people, all vehicles, all movable objects exist. Stuff that we can manipulate, stuff that is dynamic, but stuff that is very intimate and close to our lives. So reality capture presents a really great opportunity to if you create the real-time layer machine readable, imagine how the AI may help a blind person to navigate a complex world much more safely and have much more freedom to move around. So there are some. I also want to mention traffic. So if you are able to show before you turn the building, you will be able to display that a car is moving rapidly around the corner towards the intersection. That is good information to get. However, the problem is that all of this real-time information is very personal and private and sensitive. It can be the same technology that can map and index the world, can also predict individual behavior by watching facial expressions, body postures, our interactions with other people. So it's important that we treat those two layers separately. The static layer, it's fine to share it on the cloud. It's fine to have that as long as it's not a military base or some details on a nuclear facility, stuff like that. You might not want to share openly, but the general terrain and the roads, perfect. But we think there's a need for a type of firewall around what's going on with the real-time data. It needs to be on the edge, and there needs to be some sort of boundary. We need to figure this out, rules and regulations and technical solutions to enforce a firewall around the local data, so it's not aggregated centrally, and it doesn't leak to parties with ill intentions.
Do you want to go to the next slide? 'Cause
Next slide,
it's
yeah.
certainly related to the same topic.
Yeah, so the previous slide was about the two layers that represent the real world. So they are the reality capture layers. But the real benefit is when you can add layers on different themes on top of that. So you could have mobility, you could have communications, you could have infrastructure, you could have art, education, anything. It's like an infinite amount of possibilities for what you can layer on top of that. So it's not just static content, it's applications, it's experiences. So this structure of having all of this available, it presents a huge opportunity, but also a great challenge. How are you able to do this? How can a device and a browser and whatever understand all of these layers, and how can AI agents be able to figure out what the user preferences are and relate that to what is going to display to the user.
Could I advance one slide, because
Yeah.
this is still part of the same working group using the spatial index for more in the map.
Yeah. So this is something we've been working on in OpenAI Cloud for like since the inception. This is if we want to make a glue to glue the digital and physical world together. You need something that is in a shared frame of reference, so that no matter what device, no matter what service you're using, is all the virtual and real objects, they exist in the shared frame of reference. So real world objects like this thing I'm holding in my hand, it has 3 dimensions of translation, like X, Y, Z, so you can move it around, but it also have 3 degrees of freedom in how I can rotate it, roll, pitch, and yaw for people who are into aviation. If you combine those 2 in robotics and autonomous vehicles, you talk about pose, and also in computer graphics. But we don't want just any pose. We want to stick this pose to the planet, so we know exactly where on the planet it is. So we know the pose of the device, we know the pose of the virtual objects, we know the poses of other people's devices if we are working together with them, and the pose of a self-driving car. And if we are able to create this, this will be like the core chemical component of this glue. And we actually have drafted standard working groups that we want to, we hope, stay tuned, like in a couple of weeks. Open Geospatial Consortium is going to have a meeting where we present this working group proposal. And there are interested partners like Hair Maps, my company, Nordkart, the Building Smart International, that's another standards body, is interested in this. So this is perhaps the first standards effort that we are proposing. So we don't know if it's going to happen, but in a couple of weeks we know something more. We're crossing our fingers.
Okay, next slide. It's on privacy and security. Nope, that's yours.
Yeah, so as I mentioned, this is at the core, and that's really why I'm so happy that we got the XRSI initiative partnering with us. We've got some really great people already in working groups working on this, but I think now we're stepping up to a new level to really find the balance here, because you want to have the ability for people to really be in control of their own personal data. And that's a hard topic. This is not happening today. People are not in control of their personal data. So it's a long road ahead. But you cannot be absolute about these things, because there are cases when the public safety is number one. There might be a terrorist attack. There might be a natural disaster, and you need to have people maybe breaching this edge firewall that we just mentioned to get the overview of what is happening on the site. So we need to figure out how we can manage and balance those concerns. So I'm really, yeah. Maybe next slide.
Yeah. Okay. Do you want to take that, or should I? Okay.
Please.
So I think we're here at the Ericsson Experience Center, co-hosted with the AT&T Foundry, in part, important part, because 5G and the edge computing as technology enablers for the AR cloud are really fundamental. I think without these technologies arising and becoming possible in our environments, we wouldn't be where we are today. Because we, as Jan-Erik mentioned, we can't pay for or have the delays that would be caused if we were to transmit our data much further. So it's incredibly important to have this real-time layer, very rapid, high-speed, low latency layer for the real-time sharing. It's also an extension, or it's an opportunity to put in place what we just spoke about in the previous working group, the privacy and security protocols that surround the user and put in place those policies in a technical way, implementing those. There's also many high value use cases. Having edge computing and 5G involved provides us with new business models that perhaps can allow people to pay for or to enjoy these experiences in the real world without being overwhelmed by advertising. I think also one of the fundamental parts of edge computing is that much of the data that we need for AR experiences is local by definition. What happens in the objects in this room and this space aren't enhanced or augmented when I'm across or in another part of the state or the country. So the locality of the physical world can be embodied in these edge computing devices. And again, this is another opportunity to speak about how interrelated these topics and our working groups are, and what an opportunity, but at the same time, a challenge to separate out these topics. So in the subject of, Jan-Erik has already introduced to you this concepts of the static reality layer and the real-time reality layer. Where and how we distribute that is a very challenging and exciting opportunity for architects, for network architects, and for content architects. So these are really important concepts that will be discussed more in the chapter on 5G, IoT, and edge computing. I think I can go ahead. We've already mentioned a few times, and it was signified in ink here this morning, that the environment around safety and policy, and how the policy makers need to be involved as early as possible to better protect their citizens as well as their employees, wherever they may be, whether they're on an oil drilling rig in the ocean, or whether it's our children in the classroom. These regulations and policies to protect the rights of citizens, we can think about and begin working on those right away. This is a figure from the State of the AR Cloud report, and it goes into detail about how different geographies have achieved or are beginning to discuss different policy levels. There's a very important section of this report describing new opportunities and, of course, user experience. Some of the concepts are familiar to you who are already using AR presentation systems. We felt that it was necessary to lay a groundwork and a common vocabulary, because that's another purpose of this report, is to enable not only to give awareness, but to have the conversations. And these conversations around user experience and the design, the intelligent design, and the kind and conscious design, to not only enable us to have AR, but to those people who have disabilities or who are at risk in some way or another, to be included in that discussion. The hand. Okay, thank you. Just a little bit more. This is an area that Jan-Erik has mentioned already before. One of the working groups that contributed to this report is on the subject of open data and search development. Inspired, as we said earlier, by the open web and the very exciting developments, but also there's a lot of open data and geospatial that we need to be aware of and learn from the experiences, for example, OpenStreetMap, and the open government data sets, which some of you here today are experts about. Also, a lot of open data and R&D has been done around the area of machine learning, because those data sets have been provided for training, and they are fundamental to our success. So I think this is the last working group that we had working on distributed ledger technology. Of course, an emerging technology, we hear about it every day. How does it fit in? How does it enhance the security of the individual and the data, the publishers? How does it protect the rights of all the ecosystem members? So we have sections on trustless exchange, distribution of computation, automation, security, of course, profound. This is another enabler, which is part of the scope of this organization, as well as the report that we produced and are sharing with you. I think at this stage, I'd like to thank all of those companies who are Open AR Cloud partners today already, and we welcome others to join us in the future. These are companies, that's just a fraction of the many companies that are actively researching and even beginning to offer products and services in the AR cloud. But these are the ones who have a value around the vision, or who are willing to put their logo and their support behind the vision that you heard about today and is embodied in our report. I think that concludes our launch event, at least this part of the presentation. Very excited to invite you to download our report. Of course, it's the first, it's preliminary. There's a lot of gaps, lots of things we couldn't fit in. In addition, a companion to the report itself is a glossary on GitHub. It's linked to in the report, and you can find it also using the website. It's another one of the tools that we all need to use to produce a better dialogue and a stronger community and a better ecosystem for the future. So please do join us on openarcloud.org. Thank you.
Ready, I think, for the sponsors to say a few words. Are we going to have a change of computer?
That would be I don't know what happened. Did our Colin is here, or should we use?
I don't know.
You can just plug it in.
Perfect. I'll go first.
Yes, please.
Right.
Do you want my microphone? Because
I can speak up.
I can, for the
There's
streaming media, though,
HDMI
you
here.
do need the
Right.
microphone.
Just try to move this.
I'm going to snap you in
Okay.
I'm going to put this battery into your pocket.
Right.
I'm not going to take anything out of your pocket. I'm just going to put this in for you.
Let's see. Okay, good morning. I'm Jan Söderström. I'm with the Ericsson CTO team. I'm head of the technology office here in Silicon Valley. I'll give you like a 10-minute intro of what we do here. And we have launched a new concept for our lab here called D15. I'll show you a short video of what that is and talk a little bit about what we do with 5G and co-creation. I'll be followed by Perey, our head of our research, talk about what we do with immersive media here at the site as well. All right. If I'm lucky, the video and the sound will work.
This is Ericsson D15, our new co-creation space in Santa Clara, California. Named after our very first workshop at Drottninggatan 15 in Stockholm, Sweden. D15 is a tribute to our past and a vision for the future. It's a space to inspire curiosity, fuel and challenge your mindset, and ignite entrepreneurial spirit. a space to shape advanced technologies into sustainable solutions that will improve lives, industries, and society. At D15, we invite our customers, partners, and employees to engage in immersive workshops and co-creation experiences, to explore captivating demos and to shape prototypes, participate in collaborative sessions and insightful conversations, and to dare to design and to deliver powerful solutions in real time. Let's define the next generation of everything together. Welcome to Ericsson.
Okay. To get a sense, we have been here in Silicon Valley now for the last 10 years or something like that, in different forms and shapes. So we have been here at this site since 2015. We have now framed a bit the next phase of our engagement here around 5G and co-creation, all the industries that need to leverage from 5G towards a co-creation space and collaboration space and innovation space. We use words like dare, design, and deliver. And yeah, I'll show a bit more as we get going. I think the name is pretty cool. I'm a Swedish guy. And this is Drottninggatan 15. It's a building, I think it's now torn down. It was the first place where our founder, he rented a space to build his first telephones, I guess, in a kitchen. So remember this, like Californian companies are very good at telling a story. HP take people to their garage still, where they started, and everybody knows that Facebook was founded in a dorm room in Harvard. And people sort of know Ericsson's story, but we haven't told it so much. So when our American marketeers got their hands on this story, they wanted to spin it and will use it. I think it's pretty good, actually. So talking about this garage or this kitchen, I mean, there were no cars when we started to do our garage, right? So we had to do it in the kitchen. But then, of course, we've been doing quite a few things over the years. And I mean, this is just sort of the historic thing. And we don't want this to be historically back-leaning. We want this to be forward-leaning towards 5G and what comes after that, of course. And that's what all is about. So in events like this, we are just now going through a renovation or reworking of this site. So when you come here next time, it will look different. It will be more rough, more rugged, more actual work being done here in the lab. We have some things going up in the second floor here. You might see something today, I don't know. But you will get more of that. So people coming in here doing tests on top of a real 5G networks, etc. That's of course because 5G is now coming along. This is from our mobility report. We come out with that once or twice every year about what's happening in the mobile market in all sorts of metrics. But the highest metric is the number of subscriptions worldwide for different technologies. And here you see different regions, North America here, Western Europe, Northeast Asia. Green is LTE, orange is 5G. And you see the left hand or the right hand bar is 2024, the left one is 2018. So you'll see for America, over half of the users will have 5G in 2024. It's pretty significant. This picture also sort of shows a little bit of the race to be first with 5G globally. China, US, Europe. Europe needs a bit of a catch up right now, but that's okay. We like this kind of regional competition. And of course, the use cases for this 5G, we now as a telecom industry go from only sort of basically providing technology towards a consumer that has a telephone towards a market that is much more broadly. So this part here, I guess what is sort of more like the traditional market for us, the consumers that has a device. And there's a few of the stuff you're working with, of course, fits in here. To be expanded to newer areas with new potential or upside revenues, fixed wireless access being one, particularly in areas where you don't have good penetration of fiber or it's very rural, spread out. With 5G, we believe that the technology is now at a level where it definitely makes sense. Earlier attempts of fixed wireless access has not made it. This one time it will. But of course, then all the connected things, IoT of different kinds, massive IoT, which is sort of the very low power devices that use a little few bits every day or every second, that needs to just be sustainable and use low battery, to very advanced use cases, critical IoT and industry IoT, where you have robots or drones or manufacturing belts that are relying upon a 5G connection rather than a wire, and also requiring these low latencies that the technology can provide. And to bring that back to the context then of D15, now we are launching the name of D15 this year, but it's not so that we haven't been doing work in the past. So this bubble diagram or bubbles represent some kind of history, where we created the research facility here in 2008 with an early collaboration with Stanford, Berkeley, etc. I still do that. Very active with Berkeley Rice Lab. We established the smartphone lab in 2010. That was when the first smartphone started to really dominate or penetrate the market and penetrate the networks. They were actually creating problems for the operators because these were coming from vendors and application providers that didn't know telecom networks, they didn't know cellular networks. So they loaded the network with a lot of shit, a lot of extra signaling. So it was no good experience for anybody. Downtown Manhattan went down for one of the major providers in 2009, right? So it was big thing. It was Mother's Day, so many people were sending SMSs to the mothers. The network went down. So the industry operators came to us and said, hey, guys, you need to help the industry to develop their applications to fit with a telecom network. So we created a smartphone lab here. That meant putting it outside of the Ericsson firewall, make it accessible for guys like Samsung and Apple and also application providers, so they can come in and test and train. They still do that, some of them, or they still do that. We continued a few years later with device enablement when things that are not telephones in sort of in the 3GPP ways of thinking. It doesn't have a SIM card, doesn't fulfill all the sort of the standards, but still want to talk telephony or something. For example, a smartwatch or a smart speaker. They today, some of them, many smartwatches, but there's some smart speakers as well. You can do SMSs and you can do three-party calling, you can do all sort of these telephone things. And that's because we have enabled them in the network. We have exposed our APIs to these providers of equipment or end-use equipment, and we have put in entitlement servers, entitlement technology in the operator's network. So when a call comes from a sort of non-telephone, we sort of get the signaling right, and sort of we can look at, okay, should this one be allowed? Should this smartwatch be allowed to make a call? And we say yes, and then it goes. So that creates a way for us to work with the ecosystem, exposing APIs, making use cases, connecting both the application developer industries and the operators. So that's a good learning for us, and that's what we do more now. Research then started to educate the industry about 5G when the industry didn't want to listen to about 5G. So the research teams here, both here in US and also in Europe, have been run these 5G for industries. And here we have had quite a few very interesting sort of eye-opening examples on how you can do manufacturing without cable, how you can do events, like golfing events or production studios without cables, and showing that with new low latency technology you can actually make this fly. And then basically we are now launching this D15, where we're collapsing this into a full sort of end-to-end setup from Ericsson and a cloud-based setup. It's working out of here to expose our technology and drive engagements, and hoping to, I mean, this kind of events that we host with you guys here can also lead to co-development on this platform. So that's what we do. We're also very proud of the collaboration with AT&T and AT&T Foundry. So we had another event here in March where we were looking at Edge, similar things. Very proud. We got some coverage in the press, but it's clear also that it's not only AT&T that comes in. There's also operators from around the world that comes in and do things, right? But AT&T is a very close friend to us, working with this for many years. So that's D15. If there's one question, I can take it now. I'll also leave it to Pelle to continue what we do in immersive. All right, Pelle.
Thank you.
Should I take the mic? Oh yeah, yeah, it's probably a good idea.
So can you hear me? So my name is Perey. I'm heading up the research lab here in Silicon Valley and also the media-related research for Ericsson globally. And you might wonder why Ericsson is interested in AR and VR. And of course, it's because we believe it will create a lot of traffic in our network in the future. And also, as Jan was pointing out, we have these low latency aspects of 5G networks that we think will enable new kind of what we call their immersive, collaborative, and mixed reality experience. And it's because of some of the properties of the 5G networks with the low latency, the possibility to break out traffic on edge nodes and so forth will kind of enable this kind of experience in our view. And we created this D15 lab in our industrial engagement as a way of going out to the industry and say, hey, we're coming with this technology now. It's being launched in a couple of years commercially, and we want to understand if we give you these capabilities, how would you be able to use them and explore them? So it's a bit for us to go out and meet with others and co-create together with them to understand what are the requirements that will come from these kind of applications, but also to kind of teach and educate that these are the capabilities that we will bring. And in doing that, I would talk a bit about some of the use cases that we've been demonstrating over the last couple of years. And one up here is what we showed at Mobile World Congress here is that we show how you could do live music together with basically two parts of the band, half of it's in one place and the other part in another place, and then they are connected over 5G. And because of the low latency, you'll be able to get synchronization between the two parts, both in terms of audio and video. And in doing that, then you really need to keep the latency down a lot. Typically, you need to be, as with AR, VR, you know, this like 10 to 20 millisecond range. And another thing that we've seen with this kind of engagement is that a bit like the smartphones that Jan was talking about, that it's not that easy just to go in there and deploy something over this and hope that it works, because we've seen if you really want to optimize to keep, for instance, for an AR experience or VR experience, to keep the head motion to photon latency below 20 milliseconds, it's not enough just to optimize the network. You need to optimize the encoder, the processing part, where you place the edge nodes and so forth. And in doing that, it's really something that you need to do together. And we've seen in the engagement that we've been doing here that, especially when it comes to the network adaptation part and so forth, we've been very deeply involved with our partners to help them to design their application, understand how they will work the best over the 5G networks. So that's the reason for us to kind of engage a lot. And that's also why I'm very happy to see you here, because I think you're in the open AR, you seem to have the same kind of understanding that we have, is that it's not just one technology you can work with. You need to look at the whole part and how all the pieces fit together. And for us, it's not enough to go there and then launch the world's best 5G networks with a lot of edge computing and low latency and high bandwidth and everything, and then nobody knows how to use it, or it might be lacking that specific feature that would be needed. And that's what we want to learn early, and we need to work together on that. Just a very, very simplified schematic slides. I think some of the parts that you will get, and one of the key things is that the latency part that we've been talking about, is that if you have edge node deployments, you can see in our labs now, we can get between maybe 4 to 5 milliseconds from the actual device round trip delay up to the headsets in that case, compared to if you would run over the internet. I think in the best possible, if you get 50 milliseconds, you're actually very lucky, but at least it's a big difference being able to place things further out. The other thing is that in 5G, we'll talk about this dedicated slices. It basically means the possibility to set up a connection where you know the characteristics of that connection, which means that both you could know the characteristics, but you might also be able to put demands on this as well. And of course, just the fact that you know what's going on means that, for instance, if you're working with video, you know that if you compare adaptive streaming of video in today's networks, if you do that, you might have a situation where you get more bandwidth for a while, and then you think, oh, great, so now I'll upgrade my quality for a while, and then the bandwidth goes down later on, and then you downgrade it, and you would feel that maybe it's super good that you get higher quality for a while, but if you would have known that it would be decreasing later on, you probably would have made a choice to not upgrade it, because the change in the quality is also perceived as negative. So for us, it's interesting to understand what kind of interactions could we have between the applications and the network to kind of optimize the overall experience for the end users. This is a very loaded picture with a lot of numbers on it, but maybe just to point out a few things that you could be getting out of 5G that might be interesting. Talked about the latency, but also mobility aspects. You should be able to use this one also on a running train, for instance, and it should be working well. You can see the experience data rate. It's like 10 to 100 megabit, but peak rate you can get up to 20 gigabit per second. But in reality, that you can expect to be able to have these sustained data rates for a long period of time, that would be enough for really high definition type of solutions. Of course, other important part is that we have connection density and the possibility to have a large amount of devices and higher efficiency. But another thing is the global standard part. I think that's super important. That's also why this work in OpenAR is important, because if you're an application developer and develop AR, it's not enough for it to work on Ericsson networks in Sweden or Norway, or you really want it to work on every networks everywhere. So this global standard is super important. And we, of course, we're driving our part in the 3GPP mostly to make sure that the networks have the right functionality. But then, so like what you're doing in OpenAR, how will you use the capabilities here? So there's this interaction that's interesting to look at. Then, of course, if you start to think about also this about reliability and availability, if you use it for other applications than pure entertainment, then that might be more important, like remote driving and those kind of use cases. I think the other thing could be the position accuracy, that you will be able to get much better position accuracy out from the 5G networks as well. So between 1 and 10 meters inside, it might be even better than that. So you can combine that with, yes?
Well, are these criteria that you believe are necessary in order to support immersive experiences? Or
No,
is
this is what you will get.
This is what we can expect.
Yeah, what you can expect.
So you guys are going to deliver this.
Yes, that's the thing. And also, that's what I'm saying. If you see some of this one, of course, you might see that a lot of people are kind of comment on the experience data rates, but that's slow. I can get that today. But what we want to say with this is that, of course, you can get super high data rates, but the thing is the average consumer could be expected to be able to consume up to 100 megabit per second on more continuous base. So it's which is a bit of a difference. So it's a bit conservative in some parts here as well. Then, of course, it depends on how much the operators invest and those parts as well. But technology is there. Just one example that we have done together with AT&T, University of Southern California, and Warner Brothers, which I think was really interesting. It was kind of doing a really mixed reality immersive experience where you really combined AR, VR, and the physical world. And it was basically campus experience. So there were people at the University of Southern California that, went to school, and then they saw a poster one day that was asking people for an experiment in a specific lab for AR trials, something like that. And it turned out when they came there, Warner Brothers and University of Southern California built up it looked like a physical lab trial with real lab assistants there and a doctor, and you were taken in to do some lab testing, and and they build up a physical environment where you went into, where you use a hacked headset to be able to use it as an AR headset, where you combine the physical parts in this room that you could interact with the virtual reality elements that were superimposed on that. And it basically turned out to become a fight between Batman and Scarecrow, where you as the participant here could kind of help Batman out by delaying Scarecrow and so forth. I think it was super interesting, and some of the things that we demonstrated here was that things like doing remote entering at the edge node. We looked at different ways of kind of making this work in a good way, so you're not nauseous and all this, those things. And we used an early version of 5G in 28 gigahertz, and we have gigabit speeds to support this as well. We saw typically 4 to 5 millisecond round trip delay, which means that we were able to keep down this like motion to photon latency. So I think this is super interesting, but some of the things in order of time, I can go directly to some of the things we saw there is really that there's so many moving parts in this, and we really needed to work together all the way from actually the content creators and the creatives all the way down to the one working on the application itself and the networking part to make this work. So I think this is super important. Then also we've seen that this trial and a lot of other trials we've been doing, we see that there is a real potential for 5G to really change the way you create this type of experiences as well. So we kind of validated that ourselves and together with partners, as I said. Something I really think this is definitely room for more exploration around the best way, especially when it comes to partitioning of functionality. I think I like the slide I saw about how you do the environment. So some of the dynamic part might reside on the edge node. You might have different layers to that, more static parts you have in the central cloud. And I think that goes for all the functionality in this kind of experiences, the mapping, of course, but also when it comes to the rendering part. So what things are you doing in which part of the application and parts in the network? I really would like to see this one from a personal point of view, the shared 3D mapping. Yeah, I think that's super important. However, I kind of see the business model part there is probably extremely important to work with. Then, of course, the device side, for this to be really broad, I really think we want to come down to the glasses part where it's really small and battery efficient. You can use it for a full day or something like that. And I really think that offloading a lot of compute to the edge node is a really viable thing to do if you can keep the latency down, which we know that from the lab experiments that technically it could be done. So it's making it more commercially available and standardized, so forth. Yeah, another thing that also is interesting, just a notion that we also work with haptic devices. Still, the problem with haptic devices today is that we tailor it for a specific use case. And more generic haptic devices would be nice to see as well, to be able to utilize it. Okay, but I think I'll stop there. I have some more slides, so we can distribute the slides later on. And if you're interested to hear more about some of the other use cases or so forth, I think my email address is here, so feel free to contact afterwards as well.
I had a question first. So
yeah.
Do you thought of using 5G for positioning?
Yes.
Do you have any use cases or have you tried anything for that?
We have ongoing work in that. I can't talk too much about it now because I don't know exactly how much is official or not yet, but I'm interested to talk offline with that later on. Okay, thank you.
Thank you so much. Next one is Arbal from Context Grid. So you're gonna take this one from me.
Testing. Does it work? Hello, hello. It does. Oh, okay, cool. I just got that one picture. Yeah. Do we need that up now? Okay. Okay. Go ahead. Okay. Hey guys, super glad to be here. You know, Open Air Cloud, totally believe in it. You know, open, integrated future of augmented reality and everything that's in the AR cloud right now. So I'm founder of a company called Context Grid, where we're building the spatial index. That's what we focus on, and the AR browser that links to the spatial index. So we believe that for a truly universal visual browser to exist, there should be something which is similar to DNS, which is what the internet runs on. So an example of that would be, you know, like when the internet first started, we had all these silos of ARPANETs and, you know, maybe even AOL, and you'd have to go and have their own special way of accessing them. So we believe that the spatial web, if already not in that state, but it will be soon in silos, which needs to be brought together in one place. And the way to do it is to have one global registry so that you're able to find all these AR experiences which different companies are creating. And you should be able to access it with one browser. That's the aim of Context Grid. And what we're building is, like I said, the spatial index, and also an app called HoloGrid, which is actually live right now in here. So you might be able to navigate to the bathroom using it. Yeah, if you can't find it. It's actually quite hidden away, so it might help. This venue is probably too small for you to experience, you know, the true potential of AR-based navigation or indoor navigation. But we are going to be live in AWE tomorrow too, so that's a much bigger venue. I think about 300,000 square feet. So for the past week, we've been running around Santa Clara, sort of mapping the whole venue. Yeah, it was a lot of running around. I think I lost loads of weight. But it's lost. Yeah, that's why I was a bit late today. Yeah, but luckily they gave us access to the venue a little bit earlier, so we were able to run around and do all the mapping, which is crucial for some of the navigation bits to work. The key thing to note there is the mapping was done with another technology called Indoor Atlas, which is what we really deeply integrate into Context Grid. So some of the registries run using location technology for Indoor Atlas, and some with Apple, which is computer vision based. Again, this is going towards a more open, integrated feature that Context Grid and OpenAR Cloud want. So HoloGrid's live there. I think I've got a screenshot of that. Maybe Colin has it. Let's see if I can. Ah, that's the one. Cool. So that's what the app looks like. This is the button here with which you can navigate. That tells you how many holograms is in a place. So I think this one might have about 4 holograms in here. There might be a fun, like, DeLorean hologram right over there if you want to download it and try it out. They're interactive, so you can click them. They'll do things. Some of them will talk to you. Eventually, we want to link it to sort of other AI-powered Alexa behind it, so people will be able to walk around, find celebrities, or, you know, whoever you could be talking to, Bugs Bunny or something, you know. Yeah, so it's out in the iOS right now. We haven't done the Android yet, but yeah, if you have an iPhone, you should download it and try it out. And yeah, the future for Context Grid is also to keep integrating other AR cloud technologies. So that's why we're really keen to work with the whole community and bring in other SDKs, which does make the browser slightly heavy, which is, right now it's about 250 megabytes, because it's got tons of SDKs and code in it. There's no holograms, luckily, so that would have made it much bigger. But we're trying to keep the holograms light to about 10 to 20 megs. So it will work on the current sort of like 4G networks. But obviously, in the future, we want to work with 5G labs to bring in all the low latency, perhaps the position technology that I was asking her about. Yeah, so I'd love to hear more if you guys have any feedback on trying out the app. Thanks. Okay.
You're hosting special feature of our event tonight?
Oh yes, yeah, almost forgot. Yes, we're considered as hosting the after party for OpenAI Cloud. Unfortunately, we had a really nice venue in San Jose, but that got vandalized over the weekend. So we had to move the party to Redwood City. It's not that far. It's like only a 20-minute drive, and it's right on the 101. It's actually a nicer venue with like a pool and marina. So I'd love to, if you guys can make it, that'd be great. Yeah, thanks. Okay.
So now we're gonna hand it over to Tony from Brainwave. So you're gonna have this one in your pockets.
Where's that backspace?
Backspace.
Yeah.
Oh, I'm not sure. Mac guy.
There we go. That's what I want. All right, guys, this will be quick. I just want to say, first of all, thank you to everyone who's put energy and time and resources into making this OpenAI Cloud initiative work. This is really a seminal point in time when people can come together about something that's going to be so critical and transformational in its impact. I personally think that there will always be a need and a value for proprietary, highly complex and high functioning AR clouds. But I kind of look at it like an 80-20 rule, and 20% of the time we'll need those. And 80% of the time, the rest of the populace who aren't in specialized enterprise applications or medical arenas or manufacturing sites are going to need some way to get around their daily lives. And I think that this is a strong movement in that direction. So I really appreciate everyone, and especially Jan-Erik and Colin and Christine and all the others actually who put together the report. Brainwave is an emerging technology consulting firm. We've been around for almost 4 years now and study in the areas of mobility, mobile solutions, and augmented and virtual reality, of course. And lately, for about the past 2 years now, we've been intensively studying what sort of platforms and platform functionalities are going to be necessary in order to make AR proliferate. And so this is right on track. We couldn't be happier after having been working in the arena for as long as we have to see the momentum that's happening in the industry. Of course, AWE's always got some momentum behind it, but just generally, it's really exciting. I saw this picture here just a minute ago, and some of you may think this is cutesy, but I started my career as an engineer in the aerospace industry. And I worked on NASA projects, and I worked on the burgeoning commercial space field 30 years ago, before SpaceX was real. And I did that, and the people that I worked with, and some of whom I still work with, did it because it was the most bold, outrageous thing that we could imagine that humankind needed to do. The most impactful thing that we could do was go out into space, explore what's there, and bring all that back to help benefit the people of the Earth. So I was just sitting here and I was going, some of you may not be old enough that this was an impact, but Star Trek had a profound effect on many in our generation. And I was just, and I was just looking at the mission statement that occurs at the beginning of the episodes, and it says, "Space, the final frontier. These are the voyages of the Starship Enterprise to explore strange new worlds, to seek out new life and new civilization, and boldly go where no man has gone before. So, yeah. Somehow that still applies, and it still motivates the hell out of me. And who would have guessed I wouldn't have that I'd still be in the space exploration business, only now it's with you guys and it's this space. So thank you guys very much. We really appreciate it. Want to meet every one of you and understand what you're doing in the area and how we can work together. Thank you.
On the trip over here, I watched First Man with Neil Armstrong. It's very personal, intimate, visceral experience of being the first man in space. So me too. I'm a Trekkie to my heart, and the holodeck from Star Trek Next Generation has been a huge inspiration for me. So good that we are really on the same vibe there. I think we're in the part of the program where we're going to have some tech demos, if I'm not mistaken. Yeah. So, who is number one for showcasing? We got Arvisio, so I'm going to hand over.
Sync.
It really is about community, and it doesn't happen by itself. This is a great venue and they appreciate the support that Arvisio has given us as a founding member of the Open AI Club.
Thank you, Christine. Can you hear me okay, guys? Yeah, okay. Some familiar faces in the audience. And in fact, I kind of feel I'm almost home. I was in this venue only like a month or 6 weeks ago doing Designing the Edge event together with our friends from Ericsson and AT&T. And in fact, speaking about Showcase, we do have live setup on the second floor. Very much the same setup we had 6 weeks ago, running our mixed reality XR platform application over live Ericsson 5G AT&T setup. So we will pretty much, show you guys how it works. It's not perfect. It is very much early technology, and we are making good progress. It's very much usable. We have live customers that use it. But when Perey spoke about latencies and where we need to be in terms of motion to photon, overall experience, there is work to be done for sure. And good news, we are doing this work as we speak with some of the industry leaders, Ericsson's of the world, AT&T, our friends from Deutsche Telekom, Verizon, and others. So good news, 5G is, in my mind, bringing somewhat new life now into this hope of delivering truly nice immersive experience for people. Because at the end of the day, we build applications and we build things that need to be used by users, but without superior performance of underlying network and being able to deliver bandwidth and low latency to end users, this would not be possible. In fact, will never be possible. I'm a little bit biased because half of my career I spent in networking, so I never ignore a physical layer in my life because we can dream of doing a lot of things, but unless you have the foundation ready, nothing will happen. So with that said, I just wanted to introduce Arvisio to you guys. It will be a very short presentation. Seeing is believing. So we have upstairs our director of engineering, who is much more knowledgeable than me, if you want to ask him more detailed technical questions. But let me introduce our Vinje first. We are a software startup focused on enterprise XR platform and experiences. Our primary focus on industrial users, architecture, engineering, construction, energy sector, utilities, industrial, manufacturing, advanced manufacturing. So people who deal with 3D assets that are not simple, that are complex and large in nature and not easy to process, not easy to include in truly immersive experience. So we built our platform with a goal of solving this problem. I'll have, I guess my clicker doesn't work, so I'll speak a little bit about the problems and challenges, and they are absolutely pertinent to OpenAR Cloud challenges, and this is why we joined as a founding member early on, and we worked with Christine for a while and several other people in this room. So to me, one of the problems we are trying to solve is bringing complex real-life 3D experience from the industry into XR world. How do you take assets that were designed by engineers, architects, technicians, CAD, virtual designers, and bring them into interactive XR experience? And this is a challenge. There are a couple of things to be considered. One, sheer size of the models. So with mobility developing rapidly, and we've been doing work very closely with guys like Qualcomm, obviously utilizing their latest and greatest Snapdragon capabilities on new devices. At Mobile World Congress, we actually did joint demonstration with Qualcomm, taking advantage of their next generation Snapdragon 855 enabled phone, and we used what is Qualcomm calls XR Viewer. So it was Unreal glasses that you can just plug, tether to your phone, and have, in fact, experience that is very much comparable in terms of performance to industry-leading devices like Magic Leap and HoloLens. And I'm not talking HoloLens V1, I'm talking HoloLens V2 type of performance. So this was an eye-opener for me when we started working on this. All of a sudden, I could see, wow, we can enable mobile AR experience that wasn't possible before due to technological advancement in mobile AR devices and 5G network capabilities, where you can get high bandwidth, low latency connectivity to mobile locations, right? This is, for industrial users, this is very important because they don't have, Wi-Fi is great. When we're here, going around now over Wi-Fi, no problem. But the moment you want to have mobile site, industrial site, or oil and gas, or energy, there is no way to deliver good XR experience unless you have predictable bandwidth and predictable latency performance. So this is why we are so excited about partnering with people in this room. And Terence, thank you so much for helping us before and now. But we designed platform that does several important things. One, we have our underlying data engine, data optimization engine, that allows you to bring very large models, and I'm talking tens of millions of polygons. And we also have a unique point cloud data engine, data visualization engine that can process, in fact, billions of points. So we demonstrated and tested at least 1 billion points, but there is no really limit, I would say, architectural limit. But we can definitely show you the model today, which has 500 million points. And this is something quite unique. And the second important point, being able to enable this experience across multiple users. So how do you allow multiple engineers? How do you allow multiple users locally or remotely participate in this experience and take advantage of this technology? And this is something that we embarked on and made good progress. And speaking about 5G and IoT, which is real-time context of data, this is another very interesting development in the market. We started to see more and more people looking to augment XR experience with live IoT data, where you want to have this contextual data displayed in your XR experience in real time. In fact, we just a couple of weeks ago, we were at IoT World, where we demonstrated our software together with Verizon, real-time IoT data with very large point clouds in real time. And this is something that requires architecture that we call hybrid rendering approach. Hybrid rendering, in our mind, and I'll just throw a quick slide. Hybrid rendering requires several aspects. One, being cross-OS platform, so being able to support multiple devices. Today, we've been working very closely with Microsoft for a while, not as long as Mike Hoffman. Hi, Mike. So Object-C being one of the pioneers working with HoloLens, but we are partnering with Microsoft. However, we designed from the get-go our platform to be cross-OS. So we work with Magic Leap, and especially when we work with AT&T, Magic Leap becomes very important. And we support VR devices, and also now we added mobile AR, taking advantage of local rendering. So hybrid rendering approach assumes two capabilities. How do we marry local rendering for certain use cases where it makes sense to process data and visualize it on the end device in the simplest fashion with dynamic LOD, dynamic loading capabilities? And how do you address, for example, models that are hundreds of millions of polygons or billions of points that obviously no mobile device can possibly process without significant degradation of experience? So in this case, we do remote rendering. And we managed to build a platform that allows you to do it on the fly. So you can have local rendering experience and switch over. Let's say I want to get full level of details of your model with every single point. You switch on to remote rendering approach and you fill in the gaps. You get the full picture of your complex model. And this is something that is very important, and this is where we put focus of our work. And I think, I'm not going to talk about product too much. Would be happy to answer questions. But one of the things that I just described, they basically fundamentally delivering on best-in-class capabilities. And our vision is to take advantage of the most advanced technologies, whether it's Snapdragon or let's say Apple comes up one day with a good solution, whether call it XR viewer or on the phone, it doesn't matter. So how do you enable experience that allows you to take advantage of both ends? Local processing rendering, where you can handle very sophisticated models, but not super large, massive models. And remote rendering, where you can take advantage, for example, of best-in-class, and we're doing work with NVIDIA as well. In fact, here we work with NVIDIA to be able to do remote rendering of very massive data sets, taking advantage of the virtual GPU RTX server architecture. So this is very interesting, exciting. I'm excited about this opportunity as a co-founder of the company. Obviously, there is still a lot of work to be done, but it's an exciting place and space in the market where we all enjoy. And this is just an example of plan. This is point cloud. I want to highlight, guys. This is not mesh model. This is real scan of a plant. This is approximately, if I'm not mistaken, 400 million points displayed in real time. on HoloLens V1, by the way. So when I showed it to Microsoft guys, they could not believe it, that HoloLens V1 can deliver something like this. And as you see, we demonstrated this at IoT World. We have real-time sensors that come in through Verizon IoT Hub, or they call it critical asset, I forgot, services. And we were doing this in real time, and it creates opportunities for digital twin type of use cases and a lot of interesting things. My last slide, this is a demo right here at Ericsson on the second floor, where we utilize basically infrastructure, 5G infrastructure from Ericsson, AT&T, exactly what we did, Terran, 6 weeks ago. And we will be happy to show you guys later on. Please stop by, and we'd be happy to answer questions.
In the demonstration you're going to do here, what is the use case that you're going to propose?
So I think this is a very good question, because the truth is that this type of architecture can enable multiple use cases. Our focus, as I mentioned, on industrial use cases. So, for example, we're working with companies like Bechtel, KBR, very large construction engineering AEC firms. They may have a new project, and they may have a model of a new design done in Revit, and they want to scan the site and facility where they do all the design and have a point cloud. So we can marry and combine massive point cloud scan, which is replica of your physical world, with a model of a new building, let's say, or a new facility, or a new machine that you want to place there. And we can enable alignment in real time. So we have our mechanisms of anchors and alignment tools, where you can basically replicate combination of your point cloud environment with a new design placed in the real world. And you can do rough design in the office and then take this design on site and do life-size one-to-one alignment and basically do walkthrough in real time. So it can be for construction firms, it can be for oil and gas, it can be for industrial engineering, where they want, like picture here, they need to replace robots on the floor. So they get scanned, they know the location, because drawings in many cases don't represent anymore the reality. Because as time goes by, things change. People add machines, they do changes, they change layout of the floor. You get point cloud, and I think Jan-Erik knows it very well from his GIS experience, right? And we can marry physical world with a virtual content. So having this contextual information overlaid, aligned with the physical world is hugely important. This is what basically mixed reality enables. This is the most exciting part.
How do you see the alignment? Do you run that remotely on the device?
I would be happy to take this offline, because this would be going a little bit more into engineering, but we have mechanisms to do alignment. Yes.
Well, first of all, very interesting. The thing I'm interested in is, well, I guess the more general question is some of the challenges still getting the data straight out of something like Revit into your system, which I think all of us in this industry are challenged with. I'm just wondering if you're at the point where you can get that data in without ever having to touch it, or if there's still a lot of guidance on what it takes to get something directly from the CAD system into.
Yeah. It's an excellent question from someone who I'm sure experienced it firsthand. So good news, our core team has tens of years of experience in oil and gas, mining, and construction. So when we built our data import API, we have our internal extended spatial data format, where we map all the data. So when we take import, we're trying to be CAD system agnostic, and we are agnostic in many cases. So when with Revit specifically, we did plugin into Revit that basically maps into our internal format. We preserve all the data semantics attributes because for Revit models, as you know, it's very important to preserve. And we have info tools that allow you to actually interact with this data. So we preserve structure, data structure when we do import. We support 30 plus different data formats, both mesh models and like a lot of point cloud formats.
Could I ask, why did you make a proprietary spatial data format for the Visio platform, and how does it differ from what you would propose everyone to use? What's proprietary?
So proprietary is our visualization data engine inside the guts of the system. We, in fact, are big proponents of supporting open data formats. So we started, I can give you an example of AEC industry. So AEC industry and BIM was created to have an interoperable format for 3D data. So first thing we did, we supported BIM. BIM 2.3 and 4.0, all the industry. So our first strategy, support open standards. Then in some cases, when open standards, there is a reality of the industries, right? We all know, a lot of vendors talk about interoperability, and then you take their data, and unfortunately, you don't have access to 50% of semantics. So the only way to do it, so BIM is a good format. We support it. Many people use it. But some people want us to support native format. So for example, Faro or Leica doing scanning. We support natively their formats because we want to preserve all the data. We hide it from user inside. It doesn't mean that we would be happy actually to work with people on and implement underlying data APIs that is interoperable, and it's actually would make our life easier. But in terms of visualization engine, there are pretty sophisticated data visualization and optimization algorithms that took few PhDs years to develop. So it's just our differentiation and know-how. What can I tell you? And patented technology.
I was interested in the format. You answered the question.
Yes. Yes.
Is your tool go back into the tools themselves, or is it just strictly from tool to visualization, experience layer? Can someone annotate and do annotations that then feed back into, like, say, Revit? Is that the rule, or is it just one way?
So at the moment, we are doing one way. So we take data. I mean, we are working with Autodesk and a few others about this notion. Obviously, you need cooperation from the vendor to do it. They're interested in this in principle. So today we take data as is. We don't want to impact the model, right? If engineers or architects design the model, they want to preserve it. We provide experience where they can add annotations, labels, markups. They have interactions. They can save it. They can interact with it. We cannot today. It's not a problem at all for us because we have a plugin. We could do the backward operation. It just we need guys like Autodesk to cooperate. We're talking about this, but it's not there yet. Anything else? Thank you so much, guys. Thank you for your questions.
I'm from Norway, and I'm very happy that we have a partner from Finland who is doing AR cloud technology, who's at the cutting edge. I really love that. So take it away for Immersal. You're UFO, right?
Yep.
Yeah, okay. So hi, my name is Juuso Peltomaa. I'm the CEO of Immersal. We actually we have developed an AR Cloud SDK which actually works in large spaces. It's relatively simple to say that something works in large spaces, but then when you go to a really large space, then it's not that easy. Problem with the current AR industry seems to be that everyone is doing cool demo videos and everyone's having a laboratory where everything works and it's relatively straightforward to produce those kind of things. But actually, there are no large-scale AR apps published right now, and this is really worrying. I think AR as tabletop-sized AR is only a gimmick. I would compare it to the multimedia presentations of companies before the World Wide Web. It was cool to watch them in the dark rooms here and there, but then again, it was not World Wide Web. So we really need the AR cloud. So I'm happy to be here pushing the open AR cloud further. And we actually, as a company, we have a solution, and we are now here at AWE to launch our AR Cloud SDK that can enable large space AR in any app right now. And the idea is that you can just take a normal phone or headset or whatever and go around the space. For example, we AR enabled that space over there. It took about 2 minutes to walk around with a normal phone and gather the data. Then after that, we have an easy way to add in Unity editor or even in real time in the physical space to add AR content there. And that's not the only thing we actually do. Our end game as a company is to gather also in real time when people are enjoying the AR experience. We were talking about the ever-changing world here and the physical spaces tend to change a bit all the time. For example, in Finland, we sometimes have snow and we sometimes don't have snow. So the physical space can alter itself during 10 minutes. So we really need the billions of users to go around with the phones or AR headsets or what have you to get more and more data. And I believe that the value of Immersal will be at the ever-refreshing AR cloud. Then there will be probably, as mentioned here, many versions of it. Some are private, some are public, some are old, some are new, some are real-time, some are not so real-time, some are accurate, and so on. But we will definitely, one of our main assets will be the ever-refreshing AR cloud. Our business model is relatively simple, so it's 500 euros per month as a license for the SDK, and then on top of that, we will have square feet or square meter charges. So depending on how large is your physical space, then the price goes up. And we are actually riding the consumer AR wave. Well, you all know this by heart, but there's something like 2 billion devices already which are AR enabled in a way that we can use them. And just to show you that we are not only talking, I will show you a video. Hopefully this will work. There was a flash of Star Trek there. I'm a bit jet lagged. So.
The Immersal AR Cloud SDK enables 3 things. 1. Digital content anchored to a large physical space with extremely high accuracy. 2. Digital content that lives on the cloud instead of on individual devices. 3. Shared, interactive, multi-user AR experiences for thousands of people. Welcome to the era of real-life, permanent, shared AR experiences. AR apps made with our SDK are available right now, and hundreds of developers are trying it out. We're immersive, and we give you the future.
Yeah, some applause. Thanks. Sorry for that. And about our team, everyone always says that they have a cool team and experienced team, but we are, in that sense, we are ridiculous. So, for example, I myself have sold one company to NVIDIA in 2006. We got $37 million. The company was called Hybrid Graphics. I'm still pretty proud of that. And I have co-founded Zen Robotics, which is an AI and robotics company. We were the first ones in the world to make robotic recycling. So it was the 26th fastest growing company last year in Finland and all that. Our COO, Anthony, has been a CEO in multiple startups, led 2,000 people in one big Finnish corporation. Our CTO, Tatu Bloomberg, has actually just sold his legendary game company to THQ. So he's smiling a lot and he's a rich guy now. And all the Mikko is a miracle prototyper. Everyone says this cannot be done. He will come with the working prototype next morning. And all the other guys and girls are even cooler. So we really have a cool team. And we are not just talking. Actually, we have already published apps with our SDK. We have done one for Finkino, which is part of AMC Theaters, so a movie theater chain. And also our one of our customers, FlyAR, has done a construction and maintenance AR app for Caverion, a 2.2 billion euro construction company. We have also done some AR, large-scale AR work to Rovio and so on. There are some pretty cool companies. I cannot tell you all of them, but there are. I would really love to say, blurb some names, but I can say Twinkles, for example, is trying out now our SDK. They have even given us a nice quote about it. And Twinkles is, of course, the makers of IKEA Place app, the maybe largest free AR app in the world in non-gaming. Many other cool companies as well. We are really enthusiastic, and as mentioned, this is actually already working with end customers like 70-year-old grannies go around with phones and so on. So that's cool. And this just in actually last Thursday and Friday, we raised 0.9 million euros funding, which we are really proud of. And we got in, for example, Sisu Game Ventures, some angels, and also Finnish governmental organization thrown in something like 375. So it's nice. We are still raising, so if there are some well-connected people here, we are raising 0.7 million euros during the next weeks to finalize the rounds. We already have venture capital companies such as Presence Capital from Silicon Valley and so on. So do join in if you feel like it. And in more technical terms, well, you maybe all understand this pretty well, but I'll still go through with it. So the first thing is to scan the space or map the space with normal phone. And of course, from that, we will get the point cloud. The point cloud is actually a bit of an understatement because we get so much data other than the 3D points to make sure that then we can create the infrastructure for the AR. We also get what we call dense mesh, which is looks a lot like a 3D model of the place with high accuracy. We actually, in the movie theater lobby, there was a life-sized figure of Superman standing there, and because it was not moving, it got caught in our point cloud, so you can actually recognize him from the face. So it's pretty accurate stuff that we are capturing. And then, of course, why we do that is for visual positioning. Some call it even localization, but it's a language term as well. So we visual positioning ourselves. And the idea, as mentioned here before, is to get the real-time location. Within a few centimeters, we will get the device's real-time location and also the heading, where is it pointing, 60 times per second all the time. So we are really battery friendly and efficient in doing that as well. And of course, all this makes the drawing and experiencing AR possible, which is great. And we will be showing some demos in that holodeck over there. Demo number one is AR content placement demo, which means that there are some AR boxes you can drag around and or create and then drag and drop around the space. and it will be visible in real time for other users. So we will have multiple demo devices, and you can see someone dragging and dropping the box in real. Excuse me. Oh, you got the Android working as well. Yes. So now we are cross-platform. And then demo number 2, we have a Unity editor workflow demo, which basically means that it's super easy after you get the dense mesh, after you got the point cloud, then you can manipulate stuff in real time in the editor. And when you click, was it persist or what was the button name, then it will appear in the air and everyone can actually see it appearing. So once again, it's a shared experience. Our guys have actually written code for even millions of simultaneous users, so they know what they are doing. And then we can tell more about the demos then later on. I think they will be during the lunch and after the lunch, if I understood correctly. And that's about it. So if anyone wants to contact me, for example, about VC round, I'm very happy if you do so. Thank you very much. Oh, you have some.
So next one out is okay. You want to try one? Oh, there's sorry.
Even I didn't know.
Signal is
Okay, so in many like SLAM type of solutions, you'll only get stuff from 3 meters or something like that. But we have been able to get from hundreds of meters, like the point cloud, and I think that's where we are way ahead of many of the competitors. Also, of course, because we are now commercial from tomorrow on, then we are ahead in that way as well. Mikko, do you have any comments about the demo?
It almost worked, but the lighting conditions have changed since the morning.
Okay, but as mentioned, it was an ad hoc demo, and we will show you more. Okay, any other questions? Yeah, as mentioned, I'm not a techie, but it's kind of
multiple maps.
Yeah, with multiple maps, and it's kind of a relative thing where when you move around, it doesn't the error doesn't grow when you move around. Instead, we localize like to the data that has been captured from that point. So there's no way that you will walk 10 meters and then it would be 2 meters or something like that. So yes. The largest we have mapped now is something like 300 meters of a street, and there was no problem. So we are not expecting any problems, even if it would be larger. Yes, we could do. We have actually done to a phone manufacturer that I cannot name, but we have done in their office like a large space mapping. Anything else? Maybe Mikko could answer this, but the idea is that the more photos you'll get from a place, the more accurate it is. And there's basically, I would say 1 per square meter could be nice in some spaces. In some spaces, it could be 1 per 10 square meters. So it depends really a lot about how good features you can get. If it's like white walls, then you can get million photos and it still won't work. Then we will actually then fall back to ARKit and AR Core to still get the relative movement. So we are not starting to cry in those cases either. But of course, it's in some places there are lots of feature points, and in some not so much. Anything else? Okay, thank you very much.
That was cool and very brave to do a spontaneous demo. Next one up is UAR from Portland. Over a year ago, I was sort of like a fanboy of the demo videos from this company. Before I got in touch with them, it was Uri Inbar who put me in contact with them. Just like a couple of days after I told him about my idea about creating some sort of collaborative thing around open AR cloud. So from there, it's been an amazing journey, and now they're going to talk about their technology.
Hey everybody, my name is Colin Steinman. I'm one of the co-founders of OpenAR Cloud, as Jan just mentioned. In a second here, we're going to give you a demo from my day job at UAR. But before that, I just wanted to remind everybody kind of what the rest of the day looks like, just real briefly. So after this onstage demo, we've got kind of a 2-hour block where we'll be able to check out some hands-on experiences. We got a few toys around for people to check out, see immersals demos, etc. And we're gonna have some, I think, a fajita bar catered, something like that. And then after lunch, Neil Trevitt, president of the Kronos Group, is gonna come speak. And then in the afternoon, I'm going to be running a panel discussion on privacy and security in this era of constant reality capture. Oh, yes. I'm sorry, I didn't mean to cut that out. We also have interactive breakout sessions. So a few reps from various working groups within OpenAR Cloud are here. So if you have a particular interest in the UX issues, in spatial mapping, in geopose and indexing, we're going to be around and breaking out into little groups so we can have kind of more technical small discussions on that. So that's what y'all have to look forward later. And and of course the after party hosted by Context Grid afterwards. But without further ado, I want to introduce George Blickus. He is one of the lead computer vision engineers at UAR. We're a small AR cloud startup based out of Portland, Oregon. We've been at it for a few years now, and we've got some pretty cool things to show you. George?
Thank you, Colin.
While George is just starting up, are there anybody else who wants to show a demo? Some AR Cloud? Just in their pockets? Impromptu? No? Okay.
All right. Okay. Again, thank you, Colin, for the introduction. For those of you I know, it's great to see you. And for those that I don't know, I hope to meet you throughout this day. Like Colin mentioned, I'm a part of the computer vision group at UAR. I kind of wanted to touch on some points about how we sort of fit into the AR cloud picture. Earlier, Jan had mentioned these sort of keystones about the AR cloud. The standard outputs for machine readable and searchable reality, the open inclusive ecosystem participation, and personal privacy choices. And so I geared this discussion to sort of talk about those three topics and sort of what we can provide and try to contribute to the OpenAR cloud and what we have in the works for that in the future and where we feel like that should go. So a little about us. Our computer vision started in 2015. Because we had this focus on storytelling and creative experiences. And so we wanted to make sure that we could tell stories that we felt like other people would want to tell in the future, as well as being able to tell our own stories. We started going down this road using traditional visual SLAM methods. We knew that this had to run on single lens cameras with the hope that in the future companies would adopt depth sensors, multiple cameras. They've followed this lead, so that was great to see. We didn't want anything to do with markers, and we really needed a solve for geolocation-based games where doing something like Pogo, where you say, hey, in Pokemon Go, I'm near a gas station, that wasn't necessarily accurate enough for our story. We needed to say, go above and beyond that and say, you're at a gas station and you're at this gas pump, and you're looking at this key, or you need help in a certain, facet of tutorializing or getting oriented with like an Airbnb, for instance, when you go there and you want to figure out how to enter the room. So computer vision and the AR cloud just in general, we came to the conclusion that an AR cloud was necessary in order to give people valid context for what they wanted to place in the world. All these tools are great, but at the end of the day, if people can't go out and create something that has meaning for somebody else to use, whether that be industrial or social, it doesn't do, I think, any of us any good. I don't think any of us would be in here if we disagreed with that. And so it became really fundamental. It was the building block for AR objects, whatever that happens to be, whether it's models like our Visio is trying to load into the scene, whether it's industrial purpose, IoT devices, whatever it is, you need some sort of platform to lay it on. Jan-Erik was getting at this as the sort of static model that is based on the world. We call that a digital copy or real 3D space, something like that. And beyond that, it really needed to be universal. It wasn't good to just have an anchor in 3D space if you couldn't share it on an iOS device, an Android device, a headset, other software platforms. We'll get to that a little bit later. So we went down the road of making it cross-device compatible and agnostic, and we knew that computer vision had to drive these features. Recent developments in AI have been really cool to see that sort of evolve and moving from the traditional VSLAM approach that we took to a more trained method has been really cool in recent years. And so to experience the open cloud with UAR, our computer vision SDK really lets anybody access anywhere with anyone and in a variety of ways. We want to make sure that accessibility, that you can get to the AR cloud from anywhere privacy permitting. So of course, there's certain scenes, just like there are certain, like developer options as you're building your applications that you don't want people to see. There's other ones that are public and open, and everybody has the ability to go ahead, recall those, and bring them up. And like the World Wide Web, the open AR cloud shouldn't be restricted to those on personal devices. I'd mentioned that earlier, but our SDK actually achieves those goals. Again, it's also shareable with everybody. In recent developments with AR Core especially, we wanted to make sure that people didn't have time limit restrictions. So AR Core's most recent anchor system is 24 hours. I'm sure they have great engineering reasons why that's the case. But we thought that, at least for the time being, restricting an AR cloud platform to 24 hours inhibits the ability to build that AR cloud platform. And so in order to provide people the ability to do so, we sort of lift time limits on our anchors. It should be visible in the real world location it was intended, as well as remotely. So this is really where it comes together as sort of a more IoT experiment, in the sense of it's great if you can physically go to the location to experience AR. But there's a lot of it that'll probably be done offsite and away from it in a way sort of like, I don't need to be in a physical location to access a web page, but I could be if I wanted to, sort of business. And UAR for the open AR cloud. This is now going into sort of a list of features of our SDK. These are really sort of the key points and problems that we solved going down this road. We already talked about devices, but multi-anchor relocalization. This is something that is really key, we feel like, in the AR cloud experience. It's great to be able to localize to, for instance, this stage, but it's really important that when you walk into the next room, you can relocalize to that. Beyond that, it's important that as you continue walking down the street, you can relocalize to new anchor content. So we sort of use a concept of persistence across all these different anchors at a very low level. For instance, in our system, if somebody were to be creating an anchor, a kilometer away from me, and they submit it to our system, as we're walking about the space, we come upon that anchor, we can load it in and continue our experience while still having reference to the original place where we were. Some of the devices we support Android, iOS, and HMDs. There's the 6D.ai, which I hope some of you guys are familiar with. They're a really awesome iOS occlusion company, really fascinating artificial intelligence stuff. I put that in there because we also support different platforms. So occlusion is a great feature to have in AR, and I think it's something that we're all really eagerly waiting for. It's something that HMDs take advantage of using depth sensors. And on our platform, the same anchor that you create via 6D.ai, if you plug into our SDK, can be realized on an Android device that doesn't have those capabilities natively. To sort of talk about I would love to get back to somebody if they want to ask me a question about that later. There's a good sub point to that. Low-level anchor data control. I put this slide in here because with this sort of overarching concept of moving from space to space, you need low-level control of the data that represents that space. I think one thing that is currently inhibiting about platforms such as ARCore, ARKit, are that you don't actually get access to the raw data. You sort of especially in their examples, you just sort of submit it to the cloud and you're sort of at their mercy, which I mean is great if you want to get something up and running, but it forces you to always interface with their API. It forces you to always be subject to their privacy laws, their databases. And so we provide a platform in which you can do on-premise deployment. So if you want to hold the trackables on your own server for your own searching and your own querying, you can go ahead and do that. Now we have some videos actually, which are the main demo portion of it. A couple things to talk about before we go in here. There's an example of our multiple anchor system that I was talking about earlier. So a traversal from space to space in localization, excuse me. And then we have something that was we call adaptive anchor networks, which sort of solves a problem that actually happened not too long ago, in particular in changing lighting conditions. We found that that was actually one of the most crucial problems in vSLAM and Visual SLAM is that lighting conditions, although you're usually using a grayscale image to do your localization process, lighting conditions affect that tremendously. And so in the second video, you guys will see an example of how we sort of circumvent those problems. So again, this is the we call it multi-mapping or multi-anchor persistence. So each of these little gyros you guys are seeing are the individual anchors that are in this 3D space. The coloration is a visualization of the actual 3D space, that static layer that Jan has in his demos, in his slides. And so as you traverse through the space, you get on that anchor, and actually what we did right there in that last piece is we extended it. So we got to that last anchor. We realized it wasn't enough information for this 3D space, and we decided to continue it. So these are both, also on this topic, they are both being tracked to and expanded at the same time. So sort of as you're going through the space, if you notice like that blue kind of creeps across the yellow, it was actually expanding that original cloud and then realized, oh, wait, I'm actually by another anchor that's a better approximation of this space, and it loaded that one in instead. Oh, sorry.
Is this like notably different than the multiple anchors on, say, a HoloLens?
Yes. So one huge thing, again, is the cross-platform aspect of it. So we really don't lock you into picking a platform. Whatever platform you generate the anchor on, you sort of get that capability. So for instance, if you were using multi-anchors on HoloLens and it does this wonderful geometry creation aspect, you get to use that on whatever system. If you could tell me more about how they did their algorithm, maybe I would say effectively maybe the same, except for the fact that you do get to take advantage of much more platforms. Yeah. Also, the network that it adds to is in the context of like a non-walled garden, hopefully. This next thing is the we call it environmentally adaptive anchor networks. There's sort of two cases. The first one's the lighting one that I talked about earlier. And the second one is actually the first one's object-based, I believe, which is sort of like if the scene changes, if you've got a beautiful anchor of your desk and you rearrange all your papers on your desk, we sort of paint back over that. And you'll see an example of that working. And there's a color change there that I'll try and point out. We can always go over the video again. So this is the lighting change. So right now you have this pink map on the simulated morning. It goes to daytime. You have this other yellow map that loads in for the same space and the same content in that space. And then finally during nighttime, it hits this nice green tone, which pops really well with that. Those cubes are then again where those scans were created originally. This is the object going on. So right here, you can actually see a smattering of two maps here. So it's trying to decide on which one's more optimal. As we place new objects in, we'll generate a new anchor right away. Boom, everything turns yellow. It recognized, hey, you changed items on your desk. Now, one really, I think an important thing, I'm actually gonna rewind that a little bit that we should talk about is, on our platform, we have a differentiation between an anchor and which is a sort of a high level discussion about not GPS, I would say far more accurate than GPS, but more like your visual positioning. You want to describe the table but you want to describe the table through a series of changing events. In this case, it's objects. In the other case, it was lighting. So down here at the bottom, you can see this anchor trackable one. So that's supposed to be like, it's the same anchor, but the actual map we load that describes that space differs depending on changing conditions. And that's why you sort of go from anchor trackable 1 to trackable 2. And then once this scene changes again, although it's the same anchor, the map that describes the space is different. Yeah.
So is it still just you know, the 3D graph with slant points, or are you doing surfaces or something? Like what is?
Sorry, can you be more like the visualization, or are you talking about the overall architecture?
Seen it some way that you're saying it's re-recognizing it. I'm curious what the representation is.
So it's a detailed network of the space and the appropriate map for that space.
Slant feature points?
If yes, plus metadata, there's other things that we collect about the space. You know, sometimes semantic understanding is better than, you know, direct like feature descriptor match. Sometimes feature descriptors are kind of they're great, but they change. Yeah.
Talking about an open cloud, shareable cloud, accessible cloud, cross-platform cloud. Are there standards that you're using for the cloud content?
I'm glad you asked. Perfect. Can you not like exit this video easily? F? Escape? Like every time. Are we okay with tiny slides?
Yes, you do.
Okay. All right. We'll just make this bigger. Okay, so there's the environmentally evident. Okay, so the OARC and UAR computer vision. So originally, UAR actually started the Open AR Cloud Foundation, which later evolved and became the Open AR Cloud Association. We would like to develop and establish a standard for a universal descriptor file not tied to a proprietary computer vision system. We would like companies like Apple and Google to maintain their IP. We would like them to maintain their specialized features for their ecosystems, but we don't want it to be like some weird version of the web where, oh, you need to go over here and then all of a sudden I need a Google device to look at it, or you come back to the same space and to see the pertinent content, you need to get an Apple device. There should be an exchange format, and so that's what we're proposing.
Trying to connect words that we've used for decades with the terms that
Yes.
our innovators are coming up with that are different words.
Yes, I mean, and
So you have anchor points.
yes.
Well, we have tie points. We use tie points to indicate the georeferencing of the facts for a long, long time. So if we can say, oh, those are tie points, then we have a connection to
And that is why,
knowledge that would be true.
yeah, and so that's, you know, obviously why we're here is to agree on those standards, I think, to promote those standards. We also want the OARC map to expand without leaving the ecosystem. So it would be really inhibitive if like you were having a great time on an AR core device and then all of a sudden you need to stop it to use our SDK in order to expand the AR cloud or whatever, you know, the AR cloud ends up backing. So being able to plug into what our SDK represents now, but an SDK that allows you to expand that without leaving that ecosystem is very important as well. And of course, touching briefly on the privacy of users and developers, I think that's a very important topic. It's a discussion, I think, maybe for a whole, you know, later on in the day, we have a discussion about that. It's important to remember, I always like thinking about it in the context of like, we can't inhibit growth too early. So if we have, you know, it would be a shame to like limit the 100 valid open AR cloud maps we have with, you know, limitations on privacy and stuff like that, unless they're extremely sensitive at this point. And UAR in the future, we have some 3 really interesting features we think will add a lot to the open AR cloud. Primarily a concept of self-correcting relocalization. So one thing we didn't show in one of the videos, but our CV relocalization system will actually modify content position to compensate for when world anchors shift. So for instance, if you've ever used AR Core and you look at one space, all of a sudden, sometimes your content just seems to shoot off. Our system actually recorrects that and brings it back in an update sequence to where you did have it if you localize to one of our anchors. Automatic AR object refinement. This is a similar concept, but with respect to the actual content as opposed to the anchor. And that's a really niche distinction, but really important when you talk about sort of this static reference versus this runtime reference that Jan was talking about before. And of course, integrating occlusions SDKs. We have a working prototype using 60 AI, but we need to expand a more efficient system for systems like a more efficient pipeline for systems like HoloLens or Magic Leap. Questions? So we're actually taking early access partners. So if you want to visit ur.io/CV, there's a little sign up blurb at the bottom. Feel free to drop your name in there. We have an alpha SDK setup. We're looking for the right partner with the right vision. Again, we have this emphasis on storytelling and sort of creating an experience that you want to make sure is shared between everybody. So
understand it, the way you're compensating for dynamic lighting, for instance, is by having multiple maps at different times of the day. Is that what's happening?
It depends on how much the lighting changed, right? So like, you don't want it to be 10 o'clock and then all of a sudden, you load in a map for 10:30, right? Like that might not be helpful. But in that same case, it may be 10 o'clock and a cloud might cover the sun. Although you're like close to the same time sequence, we don't want to record like a brand new time of day just because a cloud covered the sun. What we do is we actually then expand the map by grabbing the previous salient features that were there and then continuing it.
But it is multiple maps for the same area.
Again, yes. So we have this concept of an anchor, which is a general description about you're here looking at the desk, and then we have this concept of the map you load in, which we call it trackable, which is sort of these differentiating metadata features about the space. Yeah. I mean, hopefully, the system becomes so efficient and so many people use it that they do become one and the same, where you sort of don't have to distinguish between those.
System designed that even if you had way better technology 2 years from now, you don't lose the content.
Great. Super. Thank you.
So those were the showcases and demos. And now we're moving into the phase where you might get something to eat and also do the hands-on. I'm sure some people are getting really hungry now. Where do they go for the food? Is it just here? It's just yeah. And also the different companies demoing their technologies will make that available now in this next period of the agenda.
Yes, we have about 2 hours, and we hope that you'll also have an opportunity to do more networking and so forth. And we're making sure that our next speaker starts at 2 o'clock. Don't go anywhere that doesn't allow you to come back. Continue in our wonderful event. Thank you, everybody. Neil Trevitz coming. Yeah, thank you, Colin. Good job.